Hi and welcome to this video. Today we're going to be looking at polynomials. So by the end of this video, you should be able to identify a polynomial and determine its degree, evaluate a polynomial for given values of the variable, and evaluate a polynomial using function notation. So a polynomial is a special algebraic expression with a term that consists of real number coefficients and variable factors with whole number exponents. So a few examples of polynomials could be 3x squared. You could have 7xy plus 5. You can have as many number of terms in the polynomial and different so polynomials with different terms have different names that we look into later on in this video. And so the degree of a term in a polynomial is defined to be the exponent of the variable. So in this case, for example, this term here has a degree of 2. And for example, in say 6x squared y, you have an exponent of 2 here and then exponent of 1. So in this case, the degree will be 2 plus 1, which gives you 3. So also in the example above, which is 7xy plus 5, you have x to the power of 1 and y to the power of 1. So, 1. And so the degree of this polynomial will be 1 plus 1, and that will give you a 2. And then another example could be, let's look at 7a squared b cubed. So in this particular example, sorry, that's a 3. In this particular example, the degree of the polynomial will be 2 plus 3. And so this will give you a total, so the degree of this polynomial will be the sum of 2 and 3, which is 5. And so say, for example, you're looking at a constant term, so you look at, say, 8. This doesn't have a variable attached to it, so we're going to assume that the variable will be x to the power of 0, which gives this polynomial a degree of 0. So the degree of a polynomial is also the largest degree of all its terms, so that's sort of the leading coefficient. So, So the leading coefficient, the degree of a polynomial is the largest degree of all its terms. So for example, you have a polynomial 4x 5 to the power of 5 minus 3x cubed plus 2x minus 1. So the highest degree in this polynomial is 5 because the term x to the power of 5, 4x to the power of 5 has the greatest exponent in terms of the rest of them, because there's x to the power of 5, there's x to the x cubed, and just x, and obviously 5 is greater than 3 and 1. So that would be the highest degree of this particular polynomial. So then let's say we're looking at 6x squared y minus 5xy cubed plus 7. So in this case, we're going to do what we've done in the previous bit, which is adding the two powers or exponents. So in this case, it will be 2 plus 1 for this term, which gives you 3. And then over here, it will be 1 plus 3, which gives you 4. And here it would just be a 0. So in this case, it's clear that the term negative 5xy cubed is the one with the highest degree in this particular polynomial because it has a degree of 4. And so, like I said before, we classify polynomials by the number of terms and the degree. So, for example, you have the expression 5x to the power of 7. So because it's only one term in the expression, we would call it a monomial, and the degree would be to the power of 7. So this would be known as a monomial with the degree of 7. So the next example will be 8x to the power of 6 minus 1, and this will be a binomial because it has two terms, and therefore bi, because bi is 2, and so then you'd call it a binomial. And it has the highest or degree of 6. And then in this case, minus 3x squared plus x minus 1 will be a trinomial because it's 3 terms, and so therefore tri. And then the same ending, which is trinomial. So nomial will be the ending of each of these, and this has the highest degree of 2 because of this term here. And then once you have 4 or 5 or 6 terms, they're known as polynomials. And then, so like for example, you have x cubed minus 2x squared plus 3x minus 4. So that's a polynomial with a degree of 3. So typically the polynomials are arranged in descending order based on their degree of each term, and the leading coefficient is known as the coefficient of the variable with the highest power. So polynomials are usually arranged in Polynomials are arranged in descending order based on the degree of each of the terms, and the coefficient with the highest power, so the one that's the first term, is known as the leading coefficient. So usually we write polynomials as n plus n minus 1 x to the power of n minus 1, so on till you get a1x plus a0, which is a constant in this case. And so in this case, this would be the leading coefficient, an x to the power of n. So for example, let's just look at this. So we have this example. So 3x minus 4x squared plus 5x cubed plus 7 minus 2x to the power of 4. So in this case, the term with the highest degree is minus 2x to the power of 4. So that's what we're going to be writing first. So 2 minus 2x to the power of 4. And then comes 5x cubed. So plus 5x cubed. And then comes the next term, which is negative 4x squared. So you'd write minus 4x squared. And then 3x, so that will be plus 3x. And then you have plus 7. So in this case, while we're arranging them in descending order, or in the right order per se, we need to make sure that we take the sign with them because that is a part of the term. So it will be negative 2x to the power of 4 plus 5x cubed. We need to make sure that the signs are right. Otherwise, when you're progressing into the next part for a question, for example, then it will be a little harder and you might get the wrong answer. So polynomials with one variable are, so we can further classify polynomials with one variable by their degree as follows. So in this case, let's look at the same example here. So we have this term here, which has a degree of 0. That means it's a constant. Then we have a term with a degree of 1. And so if we looked at this would be linear. And then say we had just this bit here up to the 7 with the constant, and then with the term with a degree of 1 and the term with a degree of 2, this would be known as a quadratic, and you might be familiar with this because this is the one most commonly looked at with addition to linear. And then we have a cubic function, or a cubic polynomial, which is when the highest or the leading coefficient of the expression or equation is cubed. And then we have a quartic, which is when leading coefficient is to the power of 4, or the highest degree of the polynomial expression is to the power of 4. So now we're going to look into how to evaluate polynomials. Okay. So now we're going to be looking into how to evaluate polynomials. So usually while you're evaluating polynomials, you're given the value for the variable, and you just need to substitute it into the expression and then simplify it. So for example, we need to evaluate 3x minus 1, and so we say that, or in the question it's given that x is equal to negative 3 over 2. So in this case, we'd have to substitute the value of x, which in this case is negative 3 over 2, into the function, which is 3x minus 1, and it's a linear function, just a side note. And so that would be 3, just an equal to there, and then to 3, negative 3 over 2, minus 1. That will give you negative 9 over 2, minus 1, and then you make the denominator. So you need to make both terms, or both of them like fractions to further simplify it, and that will give you negative 9, negative 2 over 2, which gives you negative 11 over 2. So this is how you evaluate polynomials. So we can look at another example so let's look at another example for a quadratic function. So we're going to look at how to evaluate a quadratic function. It's the same thing. You need to just substitute the value they've given you for the variable into the function and then simplify it. Expand and simplify depending on what kind of function it is. So for this example, we're going to look at 3x squared plus 4x minus 7, where x is equal to -1. So I'm just going to substitute -1 into all these values here. So that will give me 3 -1 squared plus 4. And it's always better to put while you're substituting, to put the variable into the brackets to make sure that if it's a negative sign, you don't get confused, and then you can later expand it, and it makes it easier, and it helps you avoid making a lot of mistakes while evaluating the function. So that will give you 3 times 1 minus 4, because a negative times a positive gives you a negative, so that'll be minus 7. So then you have 3 minus 4 minus 7. So we're going to start with the left side of the equation, which gives me -1, -7, and that gives me -8. So that's your final answer when the variable is substituted with -1, or substituted by -1. So there are also times where the examples have the expression has more than one term. It can have 2, it can have 3, it can have 4. So we're going to look at an example where you need to evaluate the function with a function or an expression with 2 variables. So in this case, we have minus 2a squared b plus ab squared minus 7. And in this case, they say that a equals to 3 and b is equal to -2. So we do the same thing as we did before. We substitute in both values. So 3 squared times -2. If it gets a little confusing, you can break down the function and then put the whole thing together. So we can just look at this term for now. And that it gives me -2 times 9 times -2. And that, so -2 times -2 gives me a +4. And 4 times 9 is 36. So that will be the answer for this part of the polynomial. And then we have a times b squared, so that's 3 times -2 squared. So -2 squared gives me 4, so 3 times 4 is 12. And then I have the -7. So then my final bit would just be to add them all up together. So 36 plus 12 minus 7, and that should give me 41. So that's basically how you evaluate functions and polynomials. So this was, I hope you understand. And so that was an introduction into polynomials. In the next video, we'll be looking into how to factorize and simplify polynomial functions using synthetic division and long division. Thank you. Have a nice day.